So this video is about clarifying the reflections across the x and y axes. So let's use the square root function. So if we have a parent function, square root of x, if we plot that as a domain, so the domain is that x has to be greater than or equal to 0, and the range is the same thing. Y is greater than or equal to 0. And it looks something like this. So it's square root of 0 is 0, square root of 1 is 1, square root of 4 is 2, square root of 9 is 3. So if you have the negative sign outside of the argument, so for this particular case the argument is the square root of x, but if I were to look at the other functions that we're used to using, let's just look at those. So if you had f of x equals x squared, if you had another function g of x was minus x squared, and what I'm doing here is putting a negative out front to show you that I'm not, the negative sign is not inside. It's you square x and then you take the additive inverse of it, you take the negative of it. So that's that particular parent function. If you have let's say the x cubed, then you would have negative x cubed. Maybe I'll do it this way so that that it's obvious that I'm squaring it and then I'm changing the sign. And one more. Let's say we have so we got the square root. Let's do the absolute value. So the absolute value function g of x would be negative the absolute value of x. Now all of these are x-axis reflections, because what we're doing is for a given x value we're changing the y value, and we're changing it so it's the negative of it. So this would be negative the square root of x, and this would be the square root of x. So you have this symmetry around the x-axis. Now, if you have a function where the negative sign is inside, so it's say negative x, square root of negative x, well, for one thing, the domain of this, see, the domain of this function is still that x has to be greater than or equal to 0, because we have to have the argument of the square root being positive, or 0 or positive. Here, because of the negative sign, the domain is that x has to be less than or equal to 0, because if we had a positive x value, then we'd have negative that positive value, and we couldn't take the square root of a negative number. So the domain here is all negative numbers and 0. So what happens with this case is that the negative sign inside the square root makes it reflect across the y-axis. So there's this symmetry. This point maps to that point, this point maps to that point. So this would be equal to the square root of negative x. And you see the domain reflects that, the drawing, because I'm drawing this from negative infinity to 0. It does not exist here for x greater than 0. So over here, the equivalent reflection across the y-axis would be quantity x, negative x, quantity squared. So if I had negative 2, I would x equals 2, then I'd have negative 2 squared, which is positive 4. here it would be negative x quantity cubed. Now I have to put the quantity here, this is parentheses, because it's not quite as obvious whether, if I just wrote negative x cubed, is the negative associated with the x and that's cubed, or is it the negative of x cubed? So I've drawn the parentheses. In this case, it would be equal to the absolute value of negative x. So all three of these would be y-axis reflections. Now, for this problem, because of the symmetry of the function around the x-axis, if you plotted the curves, they would look the same. The thing is that when x equals 1, y would be equal to, well, in this case, yeah, from this case, the reflection across the x-axis would look like this. So that goes with this one. If you reflect across the y-axis, it's going to look exactly like this. Because when you put say a 1 in here, x equals 1, you'll have negative 1 in the argument, but when you square it, you'll end up with positive 1. And so this, if you reflect this across the x-axis because of this, the y-axis, because of symmetry, it's going to look exactly the same. Whereas here, you're flipping it over the x-axis. Okay, now the part people have the most trouble with is this situation. So let's say g of x is equal to the square root of negative x plus 3. Now normally this would tell you, if you didn't think about it, if you didn't do this right, you'd think this was going to be shifted minus 3 units. Because if I had, let's say if I had h of x is equal to the square root of x plus 3, you might say, well, in this case, in this particular example, there's an x shift of minus 3, because all of these have the form of x minus h as far as the argument, and so the shift is h. So if you have plus 3 here, h has to be negative 3, so when you take negative 3 times negative sign, you get positive 3. So it's always opposite. Now when you have the y shift, you just do it the way you think it's supposed to be. So people look at that and they say, oh, okay, I remember every other case where I have positive x. If this is positive, then it means I go to the left, and if it's negative, I go to the right. But that is not the way to do it. What you have to do is you have to factor out a negative 1 from both terms. So you factor out a negative 1 from there, you're just left with x. If you factor out a negative 1 there, you're left with negative 3. So what this part right here is saying y-axis reflection. But you've got to have the whole parenthetical term here to get the correct shift. So when you have negative 1 times x minus 3, which is the same as negative x plus 3, what this is telling me is shift, x shift to the right. Because here I have negative 3, so that's to the right. Here I have positive 3. So let's just look at all the options, all these different functions. So if you had f of x is equal to negative x minus 2 squared. Again, it's not in the form to make the right conclusion as far as shifting is concerned. So I factor out a negative 1. So you have negative 1 times x. And to get what I have in the parentheses, all I have to do is divide this by what I'm factoring out. So negative x divided by negative 1 is positive x. Negative 2 divided by negative 1 is positive 2. So what this is telling me, this negative 1 is saying I have a y-axis reflection. this is telling me I have a x shift of -2. Is that doing that right? Yep. Let's do another one of these. Let's say f of x equals negative x plus 5, negative x plus 5 cubed. So again, what I would do is I'd factor out the -1 from both of these terms. So I'd end up with x minus 5 cubed. Again, this is saying y-axis reflection. And this here is saying x shift of plus 5. So once you factor out this negative sign from both terms, or negative whatever, if it's -3, say it was -3x, you'd factor out a -3. I guess that's the other thing too. Let's talk about that. So let's say f of x equals square root of -2x plus 4. Again, you might say, oh, I need to move to the shift to the right 4 units, to the left 4 units, if I just look at that term without thinking about what's happening over here. But what I would do is I would factor out a -2, so I'd have -2 times x minus 2. So if you divide -2 by -2, you'll get 1. If you take 4 and divide by -2, you get -2. So the sign here, this negative sign means y-axis reflection. This says it's a horizontal shrink, and this number here says an x shift of plus 2. So let's just prove this is right. So we'll open up my graphing program and we'll look at the function that we have. So the function is -2x plus 4. And let's change the view. Yeah, this is actually a little bit outside what you can see, just because of the way I normally do smart boards. So I'm going to have to stretch this thing a little bit so you can see the whole thing. Okay, so there it is. So the function I'm going to put in is the square root of -2x plus 4. So what this is saying is that I should have a reflection across the y-axis, so instead of going like this, I should go that way. And I should see that the starting point, instead of being 0, is going to be 2 units to the right. So it should start here. Instead of going this way, it's going to go that way. So let's do the square root of -2x plus 4 graph, and there you see. So you'd see the x shift is correct, and the reflection around that line is appropriate too. So you can see if you didn't factor out this negative sign or the 2, you would get 2 things wrong. You'd get the shift wrong, not only the sign, the direction, but also the magnitude.